Okay, so we're going to be using formulas in geometry. You guys are going to be pretty familiar with a lot of the formulas that we talk about today. What we're really going to be doing is talking about different ways that we can apply them, and then some specifics that are different for circles that you might not have seen before. All right, so we have a few objectives for today. Apply formulas for perimeter, area, circumference. We're going to insert some algebra into our geometry. So we're not going to just be talking about calculating area and perimeter in terms of the normal numbers. We're also going to be talking about having algebraic expressions involved and how we work with those. Don't be frustrated if you don't have all of these formulas memorized or you don't know them. The expectation is not that you memorize all of these. For any quiz or anything, you always have access to formulas that you need in order to solve problems. I'm not worried about you memorizing them. I'm worried about you knowing how to apply them and how to use them to solve problems. So the first thing we're going to talk about is perimeter versus circumference. Really, no matter what you call it, it's kind of the same concept. These are both just the distance around the outside of a shape. Generally, perimeter is when we're talking about the shape around, or the distance around a shape that has vertices or points. So a triangle, right? If we're talking about the distance around the outside of a triangle, we'll reference that as perimeter. Or a square, or some other quadrilateral, or a pentagon, or even if it's some sort of irregular shape like this, we would still call that the perimeter of the shape. Whereas when we talk about circumference, that is the distance around the outside specifically of a circle. So if we want to know the distance around the outside of a circle, we're talking about that is the circumference of the circle. But really, they kind of mean the same thing. So we have a few formulas for perimeter and circumference. Again, you don't need to memorize these, but we'll kind of talk about them as I kind of put them up here. So for a square, so this is a square. Square has all right angles, all the sides are equal. So all of our sides of this square are going to be labeled as S. The perimeter of the square can be written as 4 times S because we have 4 of the same side length, and if we multiply that side length by 4, that's going to give us the distance around the outside for a square. Again, we could also just simply add all of the lengths together, but this one's a little bit quicker if we just multiply one of them by 4. For a rectangle, so a rectangle generally has 2 different side lengths, but they could all be the same. A rectangle could also be a square, depending on what it looked like. But generally you have one length that's longer than the other one, and then one that's shorter, and that's a rectangle. It has all right angles though. So to find the perimeter of a rectangle, there's 2 different ways that we can do it. We can do 2 times the length, because there are 2 sides that are marked as L, the length, plus 2 times the width. So 2 sides here that are the width of the rectangle. Another way that we could do that is we could say the length plus the width, that's sort of halfway around the shape. If we add those together and then multiply by 2, that's the whole perimeter. So the length plus the width and then multiply by 2. Those are just kind of 2 different formulas that we could use for a perimeter. Now again, just like the square, we don't have to use a formula for perimeter. We could just simply add all the sides together and get that as our perimeter. But if we were solving a problem where we knew the perimeter and we were missing the length and we had to solve for the width, a formula is going to come in handy. So I'm going to make sure that we can use a formula today, even if we don't have to use it every time. For a triangle, there's not really a fancy formula for the perimeter of a triangle. Triangles can come in all sorts of different shapes. They're all triangles, but they could be acute triangles or obtuse triangles or right triangles. Here we just have this triangle here with side lengths A, B, and C. For a triangle, we're just going to add all 3 sides together. So the perimeter is going to be A plus B plus C. And we can do that for any shape, right? We could do that for a rectangle, or we could do that for a square as well. Just they also have other ways that we can write the perimeter that are different. And then the last one is our circle. So our circle has a few different measurements we need to be familiar with. We need to know the radius, which is the distance from the center to the circle itself. So that's our radius. And the diameter, that's all the way across the circle through the center. That's our diameter. So for circumference, we can use either of those measurements to find it out. We can do pi times 2 radius. So pi times 2 times the radius. Or we can do pi times the diameter. Those two things are the same, right? 2 times the radius and the diameter, those are the same thing. Because if you take the radius and multiply by 2, you have the length of the diameter. You might have seen these formulas written slightly differently. Sometimes they're written just with a small difference than what's written down there. You might have seen the circumference written as 2 pi r. That's fine, that means the same thing. We're just multiplying all those values together. I'm just kind of grouping them to show kind of the order that I'm going to do the things. I'll probably be multiplying 2 times the radius, then multiplying that by pi. And there are reasons to do that that we'll get in some examples here. And to show that these formulas really are just the same thing, just kind of using radius or diameter, but they're really the same thing. So those are all the perimeter formulas we need to kind of be aware of and know how to use. So next we're going to kind of quickly talk about the area formulas for these same shapes. Again, I kind of expect you already know these things, but I just want to make sure that we have a chance to briefly talk about them. So reminder, area is the amount of two-dimensional space that is inside of a figure. So when we have a shape like a pentagon here, what we're really sort of doing is we're breaking it up into a grid. Oops. I'm gonna do this. We're kind of breaking this up into a grid based on whatever units we're talking about. And we wanna know how many of these square units would sort of fit inside of there. So maybe it's something like this. And the area is how many of these squares sort of exist in there. Now my grid's not perfect, but we could sort of do a rough count. If this was my unit of measurement that I was dealing with, we could do sort of a rough count and get an idea of the area. But it's hard to do area that way. So in general, we have formulas that help us find area in a much nicer way. Because you can see, even when I made this grid, there are a bunch of nice whole squares. I know that they aren't squares here, but we'll pretend. There are a bunch of nice whole squares, but then there's all these parts. So we can't, it'd be really hard to count my area doing it this way every time. Because I don't know how much of a square this is and how much of a square that is. So it would be difficult to count area that way. But that's kind of the idea of what's taking place when we do a calculation of area, is we're trying to figure out how many of those square units make up the shape, the inside of the shape. All right, so the 4 area formulas we're going to be talking about, same shape. So we have the square. All the sides are the same. So for a square, we just multiply the side length times the side length, or we do s to the second power. So that's the same thing, right? S to the second power is the same thing as doing s times s. That's just the same thing. So the other people might reference this as base times height. Just in a square, they're the same. All right, and then in a rectangle, so same idea, we have a length and a width. To find the area of a rectangle, we multiply the length times the width, or again, some people, instead of calling this the length, they call it the base, and they call this the height. So you might see area of a rectangle as base times height, as just another way to write it. Either one is okay and fine. I'm going to be using length and width today, but it just doesn't matter. Just a different name for the same thing. All right, and then we have the triangle. So for a triangle, there is one thing that's a little bit important here. When you're finding the area of a triangle, you need to know the base and the height. And the base could be any side of your triangle. It doesn't necessarily have to be the bottom. though generally our triangles are oriented that way when we draw them, but doesn't have to be the bottom. What's important is that the base and the height, it's important that they make a right angle with one another. So it's important that the base and the height are always making a right angle. So if your triangle's not oriented in this way, where the base is on the bottom and the height is going up and down at a right angle, you want to make sure to maybe reorient the triangle, turn it so that it does match that way. So that way you have the base and the height, and they are the proper measurements to use. Because you wouldn't want to use, say, this side as your base and then this height, because this height doesn't correspond with that side right there. It only corresponds with this base. As an example, I'll just kind of quickly draw something so that we can kind of see what I'm talking about. If you had a triangle, something like this, and your say your height was measured from this point here to right here, well, this is my right angle that I'm looking at. So this could be my height. That means that this side over here has to be the base. This has to be the base that I'm using when I'm finding the area of this particular triangle. Another way you might have seen this formula is base times height divided by 2. They're the same thing. Dividing by 2 or multiplying by 1/2, those are the same mathematically speaking. All right, and then the last one, circle, pi times radius squared. So you don't want to use the diameter when you're dealing with the area of a circle. You want to use the radius, and you make sure you square the radius before you multiply by pi. You may have seen this formula written instead of pi with parentheses r squared. You might have seen it just written as pi r squared. The only reason I have the parentheses here is just to remind you that you square the radius before multiplying by pi. That's a common mistake that people do. They'll multiply by pi and then square everything. That'll get you a totally wrong answer. So just making sure we keep those in mind, the proper order of operations when we're evaluating this formula. All right, so now we're going to go ahead and look at some example problems here. And you don't have to have these memorized. You'll have access to formulas. You can look back at these if you want, or I'll also have a formula sheet available. All right, so we're going to do kind of 3 levels of some example problems here. So here we have a circle, and we want to calculate both the circumference and the area of the circle. Feel free to go ahead and work ahead of me right now. I'm going to go ahead and just kind of do them, but I'll also talk about 2 different ways that our answer could be done. So for circumference, oops, did not mean to do that. There we go. For circumference, we have a couple formulas available to us. In this case, since I know the radius, the circumference formula I'm going to use is pi times 2 radius. If I started with the diameter, I would just go ahead and use the other formula since I could. So in this case, my radius is 3 centimeters. So I'm going to go pi times 2 times 3 centimeters. I'm including the units in my calculation. You can leave the units off and then put them on at the end of your answer, but I'm just going to go ahead and put them in there just so that I remember them. So 2 times 3 centimeters is going to be 6. So pi times 6 centimeters. And then I have a couple options here. Well, I have more than just a couple. I have several options. I can do something that's called leaving my answer in terms of pi. So leave the answer in terms of pi. So pi is a number, but I can kind of not actually use the number that pi is and just kind of leave my answer. And so what that would look like is this. I would do pi times 6 is just 6 pi. I would sort of treat it almost like a variable. Now it's important, pi is not a variable. It is actually a number, 3.14 or 3.14159 or however many digits you like to use, but I could leave it like this. I could just say this is 6 pi centimeters. So this is what I mean by leaving it in terms of pi. This is one way to do that. The other way is to use one of many decimal approximations for pi. A lot of times for our class, just for simplicity's sake, I'm going to just say to use 3.14, just to keep it simple. I'm not going to mark you wrong on stuff, or at least I'll try my best to not mark anybody wrong if you use like a pi button on your calculator, because if you use a pi button on your calculator, it might be like 3.1415926, like whatever I can't even remember after that. I'm a math teacher and I only know like 7 digits of pi, so maybe that's a little embarrassing, but we'll just keep that between us. I'm going to generally just use 3.14 for simplicity's sake, but it's fine if you use a longer version. So if we're doing that, then we actually want to multiply this out. We want to say our circumference is 6 times 3.14 centimeters. And people are telling me that that's around 18.84. centimeters. So there are reasons to do both of these answers, to either leave it in terms of pi or to actually multiply it out. Usually you'll be told specifically which one to do, and if you're not, your choice, doesn't really matter. If you're not told specifically to use an approximation of pi, you can if you want, or you can do this. If you're told to leave it in terms of pi, you should use this. Again, the directions for the problem should tell you what to do, but if they don't, you get to choose. All right, so those are the two ways. In terms of pi, I'm thinking this is kind of a new thing for you, maybe, leaving your answer in terms of pi. This is something we will do, especially next semester when we do surface area and volume. We'll be leaving our answer in terms of pi a lot. But right now, you know, either one is okay. All right, I'm going to clear this real quick and I'm going to do the area. So area is pi times the radius squared. So again, I'll show both, leaving it in terms of pi and the decimal version. So substituting in my unit there, it's 3 centimeters squared. So when I do that, I'm going to get pi times 9 centimeters squared. And when I multiply that out, I could leave it in terms of pi. I could write it as 9 pi centimeters squared. Or I could get my decimal approximation using 3.14. So 9 times 3.1. I'm just going to use 3.14. If you use a longer version of pi, doesn't matter. Our answers will be just very slightly different. Again, I'm not going to mark any of them wrong. I know I'm taking a little bit of time on this problem. I just want to make sure you do understand the leaving it in terms of pi option versus the other option. And so when I do this, I get 28.26 centimeters squared. Either of these are fine, just kind of read it carefully. If you use a longer version of pi, I think you get 28.27 instead of 28.26. Again, doesn't really matter. Just depends on what version of pi. And actually, technically, what I should be doing here is this is not the exact area. It's really close, but since I'm using a rounded version of pi, even if we use the longer version, this is approximately the area. Because no matter what version of pi we use, I'm rounding it at some point. So this is an approximation. So it's approximately this. I don't care if you write equals or approximately. You want to use approximately only when you use a decimal version of pi. If you use pi and keep it in terms of pi, this is an exact answer. I'm not rounding anything here. It's not a very usable answer in terms of telling me the actual distance, sorry, not the distance, the actual size of the shape. It's hard for me to visualize what 9 pi centimeters squared is, but this is exact. whereas this is an approximation, even though it's a really good one. So recap, make sure you know how to leave answers in terms of pi, and make sure you know how to use a decimal version of pi to get an answer. The problem should tell you, but if it doesn't, your choice. All right, 2 more. So here's a kind of mid-range problem, kind of middle difficulty. We have a rectangle. So I'm going to make a picture of a rectangle. And we want to find the perimeter and the area of this rectangle. The length is x plus 1. So the length here is x plus 1. And the width is x minus 3. Express your answers in terms of x. So in this case, I am not going to get a number. I'm not going to be able to say my perimeter is 17 or my area is 34. I'm not going to be able to get an actual number answer here. My answer is going to be a variable expression in terms of x. So I need to, let's go ahead and start with the perimeter. So I can choose whatever perimeter formula I want, or I could just add up all the sides, right? We do know that these sides here are equal. So this one would be x plus 1. And this side are equal. So this would be x minus 3. So I could just add these all together, but instead of doing that, I'm actually going to go ahead and use one of the formulas because that's kind of the point of what we're doing right now. I'm going to choose that second one. I'm going to be 2 times length plus width. Doesn't really matter, whatever formula you want. So in this case, my length is x plus 1 and my width is x minus 3. So I'm going to need to substitute in the length and width that I know. So perimeter equals 2 times x plus 1 plus x minus 3. So kind of getting there, pretty close. Going to combine some like terms and go ahead and simplify this down as much as I can. So that's 2 times 2x minus 2. X and x go together to be 2x. 1 and minus 3 go together to be minus 2. And then I want to go ahead and double that. I want to distribute in this 2 on the outside. So my perimeter here should be 4x minus 4. So this is my perimeter in terms of x. That's it. That's all I can do with it. I can't actually solve for the perimeter because I don't know any other information about this problem. Kind of a mid-range problem. We're not dealing with just regular numbers. We're dealing with some variable expressions. We need to remember how to kind of substitute into a formula and simplify algebraically. So the next thing we want to do is find the area of this same rectangle. So remember, area is going to be length times width. So I'll go ahead and do that. I'll do that over here. So my length is x plus 1. And my width is x minus 3. And I am multiplying these two things together. In this case, I need to remember that I'm multiplying two things that are binomials. What I mean by a binomial is they have 2 terms. So this one has an x and a 1, and this one has 2 terms as well, x and a minus 3. There are several ways you may have learned how to multiply things out like this. The way that we teach them here at UHS in Algebra 1 is using this box method. This is just a way to organize your multiplication when you're multiplying 2 binomials. So we'd be multiplying x plus 1 times x minus 3. And then we can multiply all the proper terms together. This is one way to do it. The other way is kind of a more complicated distributive property where we do x times x and then x times minus 3. Looks good. 1 times x and 1 times minus 3. This is going to do the same thing as multiplying using the box. I'm going to do this distributive property way versus the box method way, just because this is kind of an honors level class and just making sure we can do it in this way, because it It's just generally the way it's done at a higher level. This is a nice tool, and feel free to do it this way. Yeah, and another way, another name for this is called FOIL. Stands for you multiply the first things together, the x and the x, then you multiply the outer things together, x and minus 3, then you multiply the inner things together, the 1 and the x, and you multiply the last things together, the 1 and the minus 3. So there's a few different things here, but it all comes to making sure you know how to multiply two things together like this. So either way, we're going to get x squared, x times x times minus 3 is minus 3x, 1 times x is 1x, and then 1 times minus 3. And then make sure to simplify this if we can. We have some x terms that can go together. So our overall answer here for the area should be x squared minus 2x minus 3. Right? So just making sure we can multiply those together, and we do multiply those together correctly. It's an important skill. So I'll just quickly fill this box out if that's the way you prefer to do it. X squared minus 3x, 1x minus 3. Notice filling out this box, I'm multiplying this times this to get x squared, and then I'm multiplying x times minus 3 to get that. X times 1 to get this. 1 times, it's the same thing, it's just kind of a different visual way to see what things get multiplied together. I like the box, I think it's great, but you don't have to do it this way. You can also do it this way. So again, this is my area. It's an algebraic expression. There's nothing more I can do with it. That's really all I had to do there. Okay, I'm gonna go ahead and clear this in a second, and there's gonna be one more problem here, a little bit harder, a little bit different problem. And I'll go ahead and do that, clear. All right, so the last one, algebra strikes again, yeah, is finding the area and perimeter of this shape, whatever you want to call this thing. It's like a rectangle with some bites taken out of it or something. In order to do this problem, we're going to assume these are exactly half circles. So all these are exactly half circles, and they are also exactly equal. So we're dividing it into 3 even pieces there. So if we do that, that means the diameter of each of these would be 15 divided by 3. So the diameter of each of these half circles is going to be 5 centimeters more specifically, but 5 is what I'm thinking about now. So let's talk about the area. I'll start with the area. So to find the area of this shape, there are really one way that I see it to do it, but there might be other ways you could think of to do this. I could take the area of this whole rectangle, kind of imagining that these pieces were not removed. I take the area of the whole rectangle, so that's pretty easy. The area of that is going to be 15 centimeters times 5 centimeters, which is 75 centimeters squared. So the area of the whole rectangle is 75. And then I can figure out the area of, well, just one of these little pieces and subtract them away from the 75. So that's the method that I'm going to use here. So I want to focus on how to find the area of a half circle. Well, you remember the area of a circle is pi r squared. If I want to know half of a circle, I just need to know half of that, right? So the area of each of those is going to be pi r squared divided by 2. So I'm kind of modifying my circle formula so that I'm only finding the area of a half circle. Okay, well, I don't know the radius yet, but that's pretty easy to find. If I know my diameter is 5, that means the radius is going to be 2.5. So let's find the area of one of these. It's pi times 2.5 squared divided by 2. So I'm seeing some people give me the answer. I don't know the exact answer right off the top of my head right now. So I'll calculate this, and I'm just going to do the whole calculation kind of all at once. So 3.14 times 2.5 squared divided by 2. So I'm doing the whole thing all at once. So one of those circles is around 9.815. 8125. 9.8125. So that's the area of one of these things. Yeah, thank you, Paige. So the area of one of these circles is that, or one of these half circles is this. We know there's 3 of them, so I'm going to go ahead and multiply that by 3. So that's going to be, I'm just kind of keeping track of what I'm doing here. This is 29.4375. So this is the area of these 3 half circles. So to find the area of just this shaded part, I'm going to take the area of the rectangle minus the 3 circles. So that's 75 minus 29.4375. And I went ahead and decided not to round it other than pi. You might have rounded along the way or something. Right now, that doesn't matter too much, but you want to be careful not to round too much along the way as you're doing problems like this. So I have come up with an area now of 45.5625. And remember, that's centimeters squared. So that is the area that we're looking for of this figure in here. Okay, it is 1 o'clock. I don't want to keep you guys. I'm going to finish this and do the perimeter because I'm recording right now and I want to make sure both of these are on there. Feel free to stay. I'm also doing some office hours today, some extra office hours at 1:30. So just use the same link for my regular office hours. Yeah, I believe that is the right answer from my last class. So 48.56. I think that's the perimeter we're going to get, but we'll check that in a minute. Feel free to stay if you want, or you're done as well, if that's what you'd like. All right, I'm going to go ahead and clear everything I have here and kind of quickly do my perimeter. So same idea for perimeter. I want to know the perimeter of everything, including these half circles. So I'm going to find the perimeter of one of these half circles. So that's going to be half my circumference. So half of that divided by 2. So if I kind of modify this formula, I can actually just sort of think of the perimeter or the circumference of this half circle as just being pi times r. So I'll go ahead and plug that in. We know from previously that the r in this case is 2.5 centimeters. So we're getting pi times 2.5 centimeters. Okay, so that is going to be that one of those circular sections has a perimeter of 7.85 centimeters. And just like the last one, there are 3 of them. So multiply that by 3. So I'm getting, this is 23.55 centimeters. So that is, I'm going to erase some of this here. When we say the 23.5 centimeters, what we're talking about is kind of this section. Oh. This half circle plus this half circle plus this half circle. So we've just sort of calculated the most complicated part of our perimeter there. The only thing left are the straight sides. So I can just kind of add those on there. So plus 5 centimeters plus another 5 centimeters on this side and plus another 15. And in total, that's going to give us 23.55 plus 25. I'm getting a total perimeter of 48.55 centimeters. So that is our total perimeter here. All right, and that's kind of it. This was a kind of a weirder problem, a harder problem. There's not going to be a lot like this, but we need to know how to kind of use these formulas a bit flexibly. Like, even though we know how to find the circumference of a whole circle, well, what happens when we only need to find half of a circle? Oh, well, we have 3 half circles. Well, let's find the circumference there of the half circle and then multiply it by 3. We got to be able to apply these formulas in lots of different ways. All right, guys, I'm going to go ahead and stop there. Come to my office hours at 1:30 if you need some more help, homework, or anything like that. And I'll see you guys later.